Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials version 7 course curriculum, or SRWE, and in this packet tracer tutorial and activity, we're going to be taking a look at packet tracer 4.2.7, where we're going to be configuring router on a stick in order to support Inter-VLAN routing. So remember from our previous activity, which was 3.4.5, we had multiple VLANs. However, none of the devices in other VLANs, or none of the devices in one VLAN could communicate with devices in another VLAN. And so in this scenario, we're going to facilitate that, and we're going to make that happen so that we have inter-VLAN communication, so that PC1 will be able to ping and communicate with PC3. So the first thing we're going to do is give ourselves a little bit more room with which to work here, and let's pull down router 1, and let's also pull down switch 1, because we know we're going to have some work to do here in terms of getting our router on a stick configuration to function properly. So we're going to add a VLAN to the switch. Add VLANs to the switch. We're going to configure sub-interfaces on the router, and then we're going to test connectivity and see how that plays out. So step number 1, let's add VLANs to the switch. So we're going to create VLAN 10 and 30 on switch number 1. And so let's go from user exec mode here with the enable command to privilege exec. Excuse me. And let's go ahead and say show VLAN brief. And that's what they are going to ask us to do here eventually. So let's take a look and let's see that we only have the 5 default VLANs that are configured. 1, 1000, 2, 3, 4, and 5. So let's create VLAN 10 and VLAN 30 on switch 1. To do that, we go into global config, where we're going to say VLAN 10, and I'm simply going to name it PC1. Again, no points for naming. It doesn't appear. Let me make sure that they're not going to have us name this something different. And it looks good there. So we'll just call it VLAN PC1. And then we're just going to say VLAN 30, and we're going to say the name for that is PC3. So if I say do show VLAN brief, you'll notice that we have the VLAN 10 for PC1 and VLAN 30 for PC3. Now, these are probably not the best of names to choose, because what if we start adding additional PCs, maybe a web server of some kind here or an email server? So again, not the best choice, but we're just throwing some names in here so that it doesn't give us the default, which just basically gives us the VLAN number. All right, so we're going to configure interfaces Fast Ethernet 06 and 011 as access ports and assign VLANs. So here's something to think about, right? This is where we don't want to go into interface range mode. Because if I was to say interface range, Fast Ethernet 06, Fast Ethernet 011, what we might find happening here is that I'm going to say switch port mode access, right? And we're good right there. I could even say spanning tree port fast. Now, this is a command you're going to see a lot when we get into the spanning tree conversation tomorrow evening. I could even throw spanning tree port fast on there, which means that those 2 ports are not going to transition through the listening and the learning to the forwarding state. They are simply going to immediately go to the forwarding state. And we would do this on ports where we have PCs plugged in, right? Or maybe a laptop is plugged in. So you would want that to happen. But here's the problem. What if I said VLAN, and I'm not going to hit enter here, if I say VLAN 10, remember, I'm in the interface range command. So all the other commands we've entered to this point have been good, right? We're good to go. But now we need to assign these ports to their respective VLANs. This would put both ports in VLAN 10. That would put both ports in VLAN 30. So what we'd have to do, and again, your approach to this is going to be whatever you're most comfortable with. Maybe you go into each port individually and run all the commands, or you interface range it, run the commands that apply to both ports, and then say interface fast Ethernet 0 06, and say switchport access VLAN, and that is going to be 30. And then you go into interface fast Ethernet 011 and you say switchport access VLAN VLAN 10. Got to be careful there. All right, and we say VLAN 10. So everything looks really good right now, and we can see that we're going to try to test connectivity between PC1 and PC3. And let me do the and I think it's interesting, we've got the spanning tree, the orange dot there where we typically see spanning tree active. So I'm going to hit the fast forward arrows there because we're not going to wait around for that. And we're going to test connectivity. So can I ping from PC1 over to PC3? And you know what I just noticed is there is a typo in this lab. Do you see the typo? Yeah, it's labeled PC3 down here. However, up here in our addressing table, it's listed as PC2. And here's what I'm going to say. The typo is in the addressing table. The addressing table should say PC3. This is correct. And the reason I know that that's going to be correct is they've chosen VLAN 30, PC3 30, PC1 10. And I'm pretty sure that's why they have it configured that way. And even on the sub interfaces, right? 30, 30. So I'm pretty sure that this should be right here. This should say PC3. And so we're just going to move forward assuming that that's going to be correct. So let's come back over here and let's say ping 172.17.30.10. Can I ping that PC? And the answer is no, because right now in our configuration, this port is in VLAN 10. This port is in VLAN 30. They are in different VLANs. Remember, they're like a hermetically sealed little bubble. A VLAN is a broadcast domain, is a subnet. And things inside of one VLAN, i.e. VLAN 30, cannot communicate with things inside of another VLAN on the same layer 2 switch. I caveated it there, right? Because you were probably getting ready to say, well, no. What if it's a multi-layer switch, right? I'm saying a layer 2 switch device, right? So this is why we need the router or a multi-layer switch so that we can have communication between the VLANs, inter-VLAN communication. And so let's make that happen here. And the pings weren't successful. We just talked about why we got that result. So let's pull the router up and let's dive into our router configuration. So we'll go from user exec to privilege exec into global config, and we can see that the interface is gigabit Ethernet 00. So the first thing I'm going to do is go into interface gigabit Ethernet 00, and I'm going to bring that interface up by saying no shut. And that's also going to give spanning tree time to sort itself out here on the gig 01 switch to go from the listening to the learning to the forwarding state. And we'll come back and touch on gig 01 and the configuration we're going to apply there in just a second. So here we are on router 1, right? We're in gigabit Ethernet 0. We're in the parent interface. And by bringing the parent interface up, we bring up any sub interfaces automagically that would be configured or that will be configured, that would be configured or that will be configured. So let's go ahead and grab our addressing table information one more time here. It's going to be .1 for both. So let's configure these sub interfaces. And there are some semantics here we need to pay attention to. So first I'm going to say interface gigabit Ethernet 00.10. Now, it's very important to remember that this .10 in the sub interface configuration does not have to match with the VLAN number. I could make this that value right there, right? Or within whatever the value range is going to be. Or I could say gig 00.99999. And that could be for VLAN 10. I could use that subinterface for VLAN 30. Again, I can only use it for one VLAN, but I'm saying, I could use that value for any VLAN that I feel like configuring. Now, would you do that? The answer is no. If you can avoid something like that, for troubleshooting purposes down the road. And if someone's coming behind you in that position that you have as a network administrator, engineer, whatever the case may be, you want to make it easy for them to figure things out, right? What do you want your legacy to be when you leave the position that you're currently in? You don't want people to say, oh, he was clearly practicing for a CCNA on our equipment and was configuring things that weren't best practice. He was terrible as a network engineer, right? So, and those aren't the things you want to be said. So make it predictable, right? Make things predictable. Uncertainty is not a good thing in a network environment. You want predictability. So we're going to say interface gigabit Ethernet 00.10 to match it to VLAN 10 because it's easier to troubleshoot, not because we have to. And I'm going to talk about the setting where we have to match it in just a second here. So now we're into the sub interface. You can see because the parent interface is up, the sub interface comes up auto-magically. So here we are. Now, the number one mistake that learners make, and again, the information up there is giving us the sequence of commands, the order of operation. However, this is the number one mistake learners make, is they put the IP address, 17.10.1, they put the IP address in first and hit enter and get this message, and then they think, oh, well, it's broken. Something's broken, right? Well, this is what we refer to as user error. Remember, on the trunk link that we have here between switch 1 and router 1, on the switch side, we are going to configure that port and we're going to hard code it as a trunk. And by definition, a trunk link, which is on the switch, knows that it's allowed to have multiple VLANs transit that link. That's the definition of a trunk link on a switch, is that multiple VLANs can go across that trunk link. On the router side, we don't issue the command router interface trunk like we do on switch, or I'm sorry, router mode trunk, right? Or router port trunk, right? Where we say switch port mode trunk on the switch. I don't say router port mode trunk on the router. But we kind of do say that in a different way, and that's with the encapsulation command. So we're telling the sub interface, gigabit Ethernet 00.10, that, hey, this is the VLAN for which you are going to be providing transit, for which you are going to be servicing. And it's based on that 4-byte 802.1q tag, and that value needs to match the VLAN for which we want this sub interface to service and to provide transit, right? And this is how on the trunk side, or I should say, this is how on the router side, we get it to sort of pretend and behave to be a trunk. And that single physical gigabit Ethernet 00 interface is what we are configuring here with the sub interfaces on the router so that it behaves like a trunk, that it's allowed to have multiple VLANs traffic show up, and it knows what to do, and it knows which sub interface is servicing which VLAN. And that's that encap.1q command. Once that is entered, we've declared the encapsulation. I can now come back and say IP address 172.17.10.1, and we're at the 50% mark, so things are looking good. So now let's go into interface gigabit Ethernet 00.30. And the first thing is encap.1q30 followed by IP address 172.17.30.1. That third octet in the IP address is being used to reflect the VLAN. Now, that doesn't have to match the VLAN number either, right? This 30 that's in here, it could be 99. It could be 199. However, it makes it a whole heck of a lot easier to troubleshoot things and to look at things and understand the topology when you have some symmetry, a symmetric kind of a configuration that makes sense, right? And so we'll say 255, 255, 255. Keep hitting the comma there, sorry. .0. So now we can drop the IP address on there, and it puts us at 25%. And so now let's go ahead, and it looks like they're going to talk about, so they didn't want us to enable that gig 00 interface first, but that's okay. Ultimately, you're going to do it anyway. Let me save my config here. Let's say show IP interface brief and see what we've got. So what you would have seen was that these would have been either down, or administratively. Everything would be administratively down because gig 00 was administratively down. However, we brought that port up. So here's what we see now. There's our two sub interfaces. Everything looks really, really good. So now we're going to test connectivity. Now, is connectivity going to work? And I'm going to do it in order here because I could jump onto switch 1. We could knock out the trunk port immediately, but let's go ahead and let's entertain the exercise that they want us to follow through here, because we haven't done anything on gig 01 on switch 1. And so if we haven't configured anything on switch 1's gig 01 port, here's my pop quiz for you. What type of a port is this currently going to be in operational mode? The administrative mode we know is going to be dynamic auto because that is the default on Cisco, on current Cisco switches. What is the operational state of that port going to be? Well, on the router side, do we ever say dynamic desirable or hard-coded as a trunk? No, remember, all we do is configure the router to be able to handle traffic that's showing up with 802.1q tags coming from different VLANs. We never tell it, hey, let the other side know that you want to be a trunk, because that is not what we're doing. That's not what we're doing in a router on a stick configuration on the router. However, on the switch, right, we have to do that on the switch to get it to allow multiple VLANs to transit this link. So let's take a look at switch number 1 here. Let's get into privilege exec mode, and let's say show interface trunk, right? That's the first command to run to see, hey, do we have trunk links here? Show interface trunk. If you don't see anything, you don't have trunk links on that switch, right? So we don't see anything on switch 1. And now let's go ahead and say show interface gig 01 switch port. Again, this is one of the most valuable commands on switches, right? To be able to see what is really going on. So here it is. The administrative mode, dynamic auto, the operational mode, because the other side is not hard-coded as a trunk over here on router 1, and the other side is not set up for dynamic desirable. Dynamic auto says, well, I don't hear anybody on the other side saying, hey, we're going to be trunks. No, that's not there. So it goes to an access port. Again, this is one of the very subtle things that's misunderstood by a lot of learners and network guys and gals, that if it's dynamic auto and you plug it into something that is not dynamic desirable and that is not hard-coded as a trunk, it is going to fall back to static access, right? Now, best practice, let's go ahead and knock that out. It's to hard-code it as a trunk. It's to turn the negotiation of trunking off, right? And so then we're going to come back and see, it says what VLAN is gig 01 assigned to. So show VLAN brief, and you can see gigabit Ethernet 01 is right here. And now we're also going to be answering that question, where does gigabit Ethernet 01 disappear to when we run that command later on? So we did the ping doesn't work. We know why it doesn't work. The router has multiple sub-interfaces on different VLANs. The switch connecting to it must be a trunk. So let's go ahead and enable trunking. We'll get into global config, int gigabit Ethernet 01, switch port mode trunk, switch port no negotiate. There is no native VLAN consideration here, so not a big deal. And now let's go ahead, save the config here, and let's say, what we're going to say, show VLAN brief, because we want to answer that question that I know you've been thinking about. Where did gig 01 go? How come it's not in here anywhere? How come it's not assigned to one of these VLANs? And that's the key. It's a trunk port. And if it's a trunk port, it's allowing multiple VLANs to transit it. So therefore, I can't list gig 01 next to VLAN 10 because it also allows VLAN 30. And I can't put it next to VLAN 30 because it would allow VLANs 90 and 100 and 1,000 and 55. So that's what happens in the output of the show VLAN brief command. 4 trunk links. They're gone. They just don't show up here. So when you say show VLAN brief, this is also another way to check to see, hey, are any of these ports possibly trunks? Because if they're trunks, they're not going to show up here. And again, the #1 command is show interface trunk. That is going to definitively tell you whether it's a trunk and how did it become a trunk? Was it hard-coded? Did it negotiate? What's the encapsulation on that trunk link? Is it 802.1q? And again, current day Cisco switches, everything's going to be 802.1q. Back in the day, and you might see references to ISL, which was a Cisco proprietary trunking encapsulation that nobody ever used other than Cisco. And 802.1q is the man today, right? It's the king of the trunking encapsulations. And then you can see the status is trunking, and we've got our native VLAN here. Now, could we do a native VLAN? We could. I could go create another sub-interface up here on the router, make it VLAN 99, and make that the native VLAN. So, but again, we don't necessarily have to do that. Not required. So we're at 83%. And give me 1 second here. Should be able to ping dual gateways. Did we miss something? Because I feel like we're missing something because it's acting like we're missing something. And let me check the PCs to make sure they've got default. Okay, so default VLAN is correct. And I'm sure that I skipped over something. Let's see if we can figure it out here. Let's take a look at show run on the router. And we've got the 2 sub interfaces there. .1q, just double checking the information. So everything looks good there. Our ports here on the switch, let's double check that. So PC1, fast Ethernet 011. PC3 is fast Ethernet 06. Those ports are both up. And those ports have been configured correctly. And so there's obviously something I ran by probably while talking. And let's see what we've got here. So the show trunk. Okay, if the configurations are correct, they should be able to ping their default gateways in each other. So let's make that happen. So can I ping over to PC3? And again, we may drop a packet here with the timeout. And then we've got connectivity. And if I can get to PC3, there's no question that I can get to my default gateway because that's where I would have to have gotten to in order to get over to PC3. And so again, I'm just double checking here, and I'm thinking it's the names of the VLANs that it didn't like. Create VLAN 10 and 30. And I'm wondering if that's the problem. So let me check results here and see if it's unhappy with me freelance. And of course, it's the VLAN names that it doesn't like. So I was freelancing there. Let's see. And again, I didn't see where it said. So create VLANs 10 and 30 on switch 1. Configure. So maybe it's checking. Yeah, okay, so I guess it wants the default VLAN name. So let's see, you know, it's interesting. This will be an interesting little activity here. Let's see if I say VLAN, VLAN 10, didn't want that either. Exit. Yeah, let's exit out. We'll say no VLAN 19. And so if I say VLAN 10 and I say no name, and that actually moved us up 8 points. So we'll say VLAN 30 and we'll say no name. Yeah, I haven't taken a name off of VLAN in about 1 million years. So I was trying to remember, okay, is this going to do what we need to do? And take a look at that. We're now at 100%. All right. So that is going to do it for Packet Tracer Activity 4.2.7, where we configured some VLANs. We set up router on a stick to facilitate inter-VLAN routing. Remember, if you're working with layer 2 switches like a 2960 that doesn't have layer 3 capabilities, you're going to need some sort of a device, a layer 3 device, to allow that inter-VLAN communication to take place. All right, guys, thanks so much for watching. Let me know if you've got any questions, and I hope to see you in the next video.